Welcome back. We just did this half sheet. Make sure you put your name and period. Ooh, and I forgot to put when blank is perpendicular to a blank. So hopefully you filled in the words when a diameter is perpendicular to a chord, or you could have had the words vice versa. So those are those types of questions. Now these are all the review questions you might need, and this would be homework 12, or chapter 12, homework 17B. So this grading period, I've given out 17 different homeworks. A lot of work. Okay, so I'm going to start here, and these I think we've definitely had. It says arc AB. So arc AB, I could go to the left or the right. It's definitely a semicircle, so I know the measure of it is 180 degrees. There's no other way about it. Now angle ADB, ADB. Well, it looks 90 because it is 90, because notice the tip of the cone is 90 and the snow is 180. That's 180 degrees, okay? So anytime you have an angle inscribed coming off of the diameter, the ends of a diameter, you know it'll be 90 because the snow is 180 and the tip of the cone has to be half the snow. Now let's look at this angle, BKA. BKA. Bam, it's 90 again because the snow is the other semicircle, so that's still 90. ALB, ALB, bam, 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 still 90. Come on, I'm not falling for those tricks. Okay, next question, definitely a diameter because it's going through the middle. NFH, NFH, not fooling me, it's 180, right? NGH, NGH, still not fooling me, that's still 180. Okay, NFH, NFH, the angle, bam, that's got to be 90, right? Tip of the cone, half the snow. NGH, NGH, yep, still 90. That angle is 90 degrees. Cool. Those are pretty neat. Next question, ADC, ADC is 85. ABC is the arc. ABC is the arc. All right. So that looks like the snow. So I'm just going to double this, and I get 170. So the tip of the cone, hold on, I wrote 170, and then I wrote something else. The tip of the cone, 85, is half the snow. The tip of the cone has to be on the circle. Now let's see ADC. ADC. So this arc. Interesting. We do know that arc because we know the yellow arc and the green arc add up to the whole perimeter or the whole circumference. So 360 minus 170 has to equal this arc left over. Okay, so 190. And double check, when I add them together, I get 360, so I'm good to go. So now working backwards, we can say, what is angle ABC? ABC, this angle. Well, this angle has green snow, and we solved for the green snow. There's 190 degrees of snow there. We just solved for that. So this would have to be half of that, 85. No. Half of 190, I don't have a calculator, but if I divide that in 2, I get 95. That makes more sense. 95. Okay. So we actually proved something a long time ago. It was back, I think, in homework 11. We proved that these two numbers have to add up to 180 because if this snow and this snow add up to 360, these two numbers we're going to cut in half and add together. So those will have to add up to 180. So just double checking, these two angles have to add up to 180 if it's a four-sided shape trapped in a circle. Okay, so that's something important to remember from the last chapter. PRM, PRM, RM is 70. That means we know this snow is 70 times 2, also known as 140. So PKM is 140. We now know PRM, it's whatever is left over from 360 when I subtract 140. That looks like 220. Okay, so working backwards, if I write PKM, the same thing happens. Half of that, this angle has this yellow snow, so that would be the angle. Half of 220 is 110. Notice these two angles, once again, add up to 180. So it should come as no surprise that that pattern will continue no matter what. Now take a minute, make sure you put your name, date, and period. That's always a good idea, right? Okay, get it. I get a lot of homework, people don't have names on it, so you can't get credit unless I know whose it is. Now let's take a look. We did a bunch of these in homework 13, so let's just do a couple now. So on the back of one of my sheets, I'm just going to write this out. Area is equal to 36 pi. Well, the formula we need to have memorized is area is equal to pi r squared. So some kids can actually see that there. It's like, ooh, I know the number they squared to get that. Other students might use algebra to solve. So if I divide pi on both sides, notice I get 36 is equal to the radius squared. Well, I've got to take the square root of both sides so that I can get to the answer r is equal to 6. So let's work the problem forward. If the radius was 6, the area is equal to pi radius, or the number 6 squared. So you should realize that the number, that makes sense. That would give me the answer 36 pi, because 6 times 6 is 36. Now if the radius is 6, then the diameter is 12, and the circumference is 12 pi. How did I know that? Well, the circumference is equal to 2 pi r, or you can also memorize the formula pi times diameter. So if I know the diameter, I just multiply by a pi to find the circumference. Good job. Now feel free to pause the tape and then see if you got it right, or just keep following along. So question 6 says the circumference is 10 times pi. Well, we just used the formula. The circumference is pi times the diameter. So I know the diameter has to be 10. I could use algebra to also prove this method. So if the circumference is pi times 10 times pi, and the formula for circumference is pi times diameter, if I merely divide by pi on both sides, I get diameter is equal to 10. I can work the problem forward as well. So again, if the diameter is 10, circumference is pi times diameter, so 10 times pi. That's exactly the circumference I got. This would make the radius 5. So again, we know area is pi radius squared, so this would have to just be pi, and when I square the radius, I get the number 25. All right. Now these are pretty easy. If I square root the both sides, I get 7, right? Now I could say, and it would be true, plus or minus 7, but the radius is a length and we only want the positive number. So if we take the square root, that's 10. Take the square root, it's just the plain old square root of 8. I leave my answer that. There's a couple ways also to leave your answer, but that would be one answer, because 8 is not a perfect number. 4 times 4 is 16. Okay, last one. We're going to do these pizza ones. And you could also think of these as a clock. So we cut, just like a clock is cut in 12 equal slices. Just like a clock. Okay, so I cut a pizza in 12 equal slices. Jim ate 5. So if I started at 12 o'clock, 1, 2, 3, 4, 5. Jim ate 5 out of the total of the 12 slices. So what is the central angle? Now, logically here, we know that the central angle here all the way around is 360, but I don't want the whole central angle. I only want a part of the central angle. So if you think about it, I only want 5 out of 12 of the central angle, which we know is 360. Okay, so to get our answer here, we want to say the central angle would have to be 5 divided by 12 times 360. So 5 divided by 12 times 360. So if you have a calculator, you can go ahead and work through it, but I don't. So I'm going to have to factor it out. It's kind of a pain, but I'm going to do it. So 12 times 3, 12 times 30 would also give me 36. So I've just rewritten the problem. And if I cancel the 12, I get 150. So if you did this in the calculator, 5 times 360 divided by 12, you should have also gotten 150. I just showed you another way to do it. Sweet. Now it says the uneaten slices. So if he ate 5 slices, that'd be 7 slices. And the central angle would be just whatever's left over from 360. So that would be 210. Cool? Now it says Kim ate 4/7 of a pizza. So that's 4/7 times 360. That's going to be a decimal. So you can turn that into a decimal, I think, or just leave it like that. The uneven pieces, so that means she didn't eat 3 out of the 7 pieces, right? And that would be 3/7 of 360, and of mean multiply. You could turn those into decimals or leave it just like that. Thanks for joining us. See you next class.